good afternoon all. Today we'll be looking at binomial distribution of probability. And this topic, binomial distribution of probability, is trying to talk about the probability of success and the probability of what? Of failure. We're trying to talk about two things here. One, the probability of success and the probability of what? Of failure. The probability of an event happening at any single trial is referred to as what? The probability of success. Whilst the probability of an event not happening is what we refer to as what? The probability of failure. So this is what this topic called binomial distribution of probability is based on. It's just based on the probability of success and the probability of what? Of failure. So before you solve problem on this particular topic, you need to know this formula. So this is the formula to know whenever you are asked to what? You are asked to solve problem on binomial distribution of probability. For the P, it means what? It means probability. This P means what? Probability. This small x means what? The number of successes. This small x means number of successes. And this n means what? This n means the number of independent trial. The n means the number of independent trial, and the p means what? Probability of success, whilst the q means what? The probability of failure. So this is the formula to use whenever you are asked to solve problem on binomial distribution of probability. Let's take an example, a very first example on this particular topic. Mind you, don't forget the formula. The formula says and mind you, this C means what? Combination. For us that have treated permutation and combination, you know this C represents combination. This P here represents what? The probability of success, as I said earlier on. This Q represents the probability of failure, and this X represents the number of successes. The n represents what? The number of independent trials. So let's take our very first example. Example 1. Um, so this is the question. This is our very first example. Um, this example is trying to say, in a community, 13 out of 20 students speaks English. If 8 students are selected at random, find to correct significant three significant figure the probability exactly 2 students speak English. So the requirement here is what? Is to find the probability exactly 2 students speak English. That is the requirement. And first, we need to collect data before we start. First, earlier on, I said this is what? The number of words. The number of independent trials. The N. The C is what? Is the combination. X is what? The number of words of successes. P is what? The probability of what? Success. X, okay, I've said it earlier on. Q is what? Is the probability of failure. And if you watch here, in a community, 13 out of 20 students. So what? The total student is what? Is 20. So it refers to as for the sample space. Sample space. The total student is what? Is 20. So it is referred to as what? The sample space. From the what? In a community, 13 out of 20. So what? The successes are what? Are 13. You see, 13 out of 20 what? Speaks English. So what? In a community, 20 students. We have 20 students in a community, but what? Not all of them speak English, but what? They say what? 13 out of 20 speak English. So what? Out of these 20, 13 students speaks English. So what? We say, so this 13 is what? Is the probability of what? The probability of success. So we say the P, which is refers to as what? The probability of success is equal to what? 13. 13 all upon what? The sample space, which is what? Which is what? 20. This is the way to find the probability of what? Of success. It's very simple. First is what? In a community, 13 out of 20. What is the total? Is 20. The total is referred to as what? The sample space, which is 20. Then what? We are now to find what? The probability of what? Of success, which is what? 13 upon 20. This 13 is what? Is the probability of success all over what? All over what? The sample space, which is 20. So now we are now to find what? The probability of what? Of failure. How do we find the probability of failure? To find the probability of failure, here is what? Either we use the formula, P plus Q equal to 1, or what? We need the other way. But let's see this formula. What is P? P is what? Is the probability of what? Is the probability of success. So P is what? 13 upon 20 plus what? Plus Q equal to 1. We want to make Q the subject. We say Q is equal to 1. We transpose. Mind you, when it transpose, the sign changes. So we complete the fraction. We are now finding the probability of what? Of failure, which is Q. So we say 1 upon. So our LCM here is what? Is 20. 1 into 20 is what? Is 20. 20 times 1 is 20. 20 into itself is what? Is 1. 1 times 13 is 13. 20 minus 13 I think is what? Is 7 upon 20. So 7 upon 20 is what? Is what? Is the probability of what? Of failure. 7 upon 20 is what? Is the probability of failure. This is what? One of the methods used to what? To find the probability of what? Of failure. Let's take the other method. The other method is what? First, the sample space is what? Is 20. So what? You say our you say what? 13 out of what? Out of 20 speak English. So if 13 out of 20 speak English, so the remaining are the ones that do not speak English. So it's like this. You say what? 13 out of 20, it means what? You are going to subtract 13 from 20. It's what? It will give you what? 7. These 7 are the ones that what? That do not speak English. 7 upon what? Upon the sample space, which is 20. So this is the what? The other way to find what? The probability of what? Of failure. 7 upon 20. So now this is what? We will find the probability of what? Of success, the probability of what? Of failure. And according to the formula, I think write the formula. According to the formula, we'll find what? The probability of success, the probability of failure. We are now to find what? The number of what? The number of independent trial, which is n. We are now to find the number of independent trial, which is what? Which is n. Number of independent trial, n. From the question said what? If 8 students are selected at what? At randomly. If 8 students are selected at what? At random. This means the selection is not based on what? On the student that what? That speaks English. What? It's based on what? On whether what? You speak English, whether you what? You did not. The selection based on everywhere. So that is why the question goes like, if 8 students are selected if 8 students are selected at random, it is independent. That is why we say what? The number of independent trial. So since 8 students are selected at random, so 8 is what? Is the number of independent trial. So 8 is the number of independent trial. From there it remains what? Our number of successes. From the requirement, we are asked to find the probability exactly 2 students speaking English. So since exactly 2, so our number of what? Our number of successes, which is x, is what? Is 2. So this is our number of what? Our number of successes, which is x. So now let's find the requirement. Requirement is what? Is say the probability exactly 2 students speak English. This is the what? The requirement. We are going to solve this question asked by what? By following the rule of the formula. What is n? That is equal to, what is n? N is what? N is what? Is the number of independent trial, which is 8. 8 combination what? X, what is x? Number of successes, which is 2, multiply by what is p? P is what? P is what? Is the probability of success, which is what?